Class, it occurs to me that we're dealing with reactions that either absorb or give off energy when we're looking at thermochemical processes. And if we combine that with the idea of stoichiometry and the idea that when a certain reactant is available in excess and another one is not, that the reaction is limited by the amount that's not in excess, the limiting reactant, what I thought we might be able to do is do a titration that uses temperature change as our indicator. That is, to do a thermochemical titration. Never done this, never tried it, never even thought about it before. I thought about it, and I figured we should just give it a try and see. So what we're going to do is we're going to do an acid-base titration and watch the temperature change as we add one of the reactants to the other and see if we can detect an endpoint, and from that figure out what the concentration of one of the solutions is if we know the other. Okay, so we're going to do our titration. So the first thing we're going to do is we're going to add our base to the burette. So we've got our solution of 3 molar sodium hydroxide here. And the first thing we're going to do is we're going to make sure our stopcock is on the burette is closed so it doesn't dribble down when we add it. We're going to put our funnel in. We're going to slowly add this in there. We're going to add it kind of up near the top, but we're not going to go all the way to the top. So we're going to do this slowly. 3 molar sodium hydroxide is pretty strong, so we're going to be extra careful. Okay, so that's up to about 3 on the scale there. Before we do anything else, I'm going to close the lid for that for safety's sake. I'm going to clamp this into the burette clamp. And what I'm going to do is I'm going to release a little so that the burette tip is filled with liquid. Do that slowly, otherwise it can develop air bubbles. Okay, so that's good. We're going to remove the funnel because it might drip liquid down and interfere with our measurements. Next, we will measure the beginning point for the titration. It looks to be about 5.25 milliliters. Okay, so now what we're going to do is we're going to add our acid to the cup in which we're going to do the reaction. We're going to use this styrofoam cup so it won't absorb much heat. And we've measured out 27 milliliters of our acid solution. So we're going to add that to the cup. And also to that, we're going to add a stir bar because we're going to stir the reaction as it's happening to make sure that the heat is mixed. So we're going to put that under there. And then we're going to add our temperature probe. Put that over here so that you can see it. Or can you see it? You can see it right there. Okay, so now I've taken the lid to the cup and I've cut a hole in it that we'll use to put the pipette tip as well as the thermometer, the temperature probe. So we put this on here. So remember our acid solution is already in there. We're going to drape the temperature probe over a clamp and put it down the bottom. Yeah. Okay. Let's make sure our stir bar stirs before we go. Does indeed. Okay, we're ready to go. So our initial temperature is 22.9 degrees, or 20. Let's see about this. 23.1 degrees. What I'm going to do is I'm going to add the base in at 1 milliliter increments. See what the temperature does. Okay, so we're starting around 5.3. We're down to 6.3, and the temperature is now 24.5. 7.3. The temperature is 26.1.
around 8.3, 27.4, 9.3, 28.7, 10.3, 29.8, 11.3, 30.8, 30.9, 30.9, 12.3, 31.8, 13.3, 32.6, 32.7, 14.3, 33.5, 33.6, 15.3, 34.2, 34.3, 16.3, 35.1, 17.3, 35.6, 18.3, 36.3, 19.3, 36.9, 20.3, 37.4, 21.3, 37.9, 38.0, 22.3, 38.3, 23.3, 38.7, 38.8, 24.3, 39.3, 25.3, 39.7, so it's still continuing. 26.3, 40.1, 27.3, 40.4, 40.5, 28.3, 40.2, 40.1, 29.3, 39.7. I think it's working. Feeling good about this. 30.3, 39.4, 31.3, 39.0, 32.3, come back, 32.3, 38.6, 33.3, 38.4, and 34.3, 38.0. We'll just stop after this one. 35.3. We're down to 37.7. 37.6.
So we're done with our titration. It looks like the temperature did go up to a certain point, and then when we added more and more base, then the temperature started going down again. So we'll make a plot of this and figure out exactly or roughly what the concentration of that unknown acid solution was.